Hello everyone, welcome back to the channel, and we are back here with the restoration of the Philips tuner. As you see, I put the chassis in my bracket here, so yeah, then it's easier to handle. As you saw in the last video, I fixed both the tuning dials here, so FM and AM are both working perfectly fine now, so that's great. I also, in the meantime, fixed the switching, and I also cleaned the entire top side of the chassis. I'll show you that later. The switching, as you might remember, most of the switches were really stuck, but now, after thorough cleaning, everything is working perfectly fine. See? Perfect. This one is just a simple push button, and that's also now working fine. This is for the band spread. The other ones are radio buttons. This is a on-off switch for the band spread. That one also wasn't working very well. It was always either not registering or it was getting stuck. Yeah, and cleaning was quite easy because yeah, I can, as I already showed in the last video, the switching mechanism is really accessible here. So I took my normal approach, the three-step approach, first with the contact cleaner, then with the washing liquid, and then with the corrosion protection, this one over here, and that solved it quite easily. And look how clean she is. I cleaned the entire top side of the chassis and it's looking really great. As I said, there was a bit of tarnishing on the chassis, but it's only basically here on the back end side. The rest of the chassis is really nice and cleaned up very well. So yeah, I am really pleased with this result. Yeah. Yeah, see, so this is an easier way to see the switching mechanism, and here you can clearly see the switches moving. But a lot of radios this is covered and it's really hard to access, but here, yeah, it's really easy to clean everything nicely. Now, I have been looking a bit at the schematic and at the service manual, and I did find some interesting things about it. And there is some interesting explanation as well in the service manual on how the tuner is working, basically. So maybe it's interesting to take a look at that one first. Alright, so I have here the service manual, and the service manual is entirely in Dutch, which is quite convenient for me because Dutch is my native language. And we're going to go quickly through it because there are a couple of really interesting things to mention here. Alright, so in the beginning we simply have here a title page with some characteristics and some features. So notice 1958. So then next we have some very interesting pages with some technical explanation on why certain choices were made in the schematic and in the design of the electronics. And we're gonna come back to that later. I'm just gonna skip it for now, but that's I wanna talk about these things later. Then we have here afregeling van de tuner. So this is the alignment instructions that I'm not gonna do in this video, so I'm not gonna skip that for now. So this is the AM, this is the FM. Then we have a list of parts and their service numbers. It's not really useful anymore these days. Then a list of all the components and their values, which can also be quite convenient as a reference. Then we have the schematic. Obviously, we're going to come back to that later as well. But as you already see, it's quite extensive for just a tuner. And then we have the typical Philips wiring diagram, which I find extremely useful because this really is a visual representation of how the radio is wired and how all the connections are made. So you can really pinpoint like a resistor or a capacitor here on this diagram, like for example, let's say this one over here. And you can see, yeah, look, that's C14. So you immediately can map the values of the components onto the physical tuner itself. So that's really convenient to find a certain resistor or a certain component in the schematic, or the other way around. If you have the schematic and you want to know where, for example, here is C19. So let's say I am repairing here something in this area, and I want to know where is capacitor C19 located in the tuner itself. Then you're just going to go here to this diagram. You're going to check here in the table above, C for the capacitors. Let's see, where is 19? You just skip over the entire row here. Voila, here we have 19. So then you go straight down, and here we have it, C19. And so this is really convenient to locate a component from the schematic, or the other way around. If you have a component in the tuner and you want to know where it is on the schematic, you simply read here the value. For example, again, C19. Want to know where it is on the schematic, you do the same thing here. You check in the top column, you check, and you find here 19, you go straight down, and here it is on the schematic. I really love these drawings from Philips. They make life a lot easier. This is the drawing for the bottom part of the tuner, and this is the top part. Yeah, obviously it's rotated 90 degrees here, but you get the gist. It's the same thing. Moving right along, we have here the drawing for the tuning dials. And then we have some service bulletins, which is quite nice to see. Here they basically say that there is a separate type of tuner, an A5X83A/05, which is the same device except for example, a different cabinet and a different couple of different other components. Yeah, this is the same thing, but in different languages. This is also quite funny. This is also a service manual from 1964, so that's 6 years later, where they say, yeah, from lots of different sources, from, for example, stores and also customers, we got the request to make this tuner stereo capable. And for this, we took the following actions. So here they say what you should practically do, where you should bring the tuner, and then they say that the costs to convert your tuner to stereo are 120 guilders, including shipping. So yeah, that's pretty nice. And then a remark, this conversion does not include a stereo indicator. So remember in the last video I said that the stereo version of this tuner had an indicator, an extra light bulb to indicate whether you have stereo or not. That's not included when you want to convert the mono version of the tuner. And then here they have a complete explanation on the conversion if you would like to do it yourself. So these are the steps that you need to follow to convert the tuner from mono to stereo. Obviously, you then need a stereo decoder. So yeah, converting it still today is going to be difficult if you want to do it in a contemporary correct way, because you'll need to find the decoder, the stereo decoder somewhere. And this is the list of parts that you need if you want to convert the tuner to stereo. So you have here a decoder, there's some brackets and a new backplate, and then you have some simple resistors and capacitors. That's not an issue, but these things over here, yeah, I guess you'll not be able to find them anymore. And this is the schematic for the conversion, where here this box is basically the stereo decoder. All right, first, so now let's have a look at the schematic. Let's start with the power supply section over here in the bottom right corner. That's quite simple. You have the mains coming in, you have the on-off switch, you have a fuse, then the transformer. You have one secondary, which is immediately rectified by the EZ80. So you have here the B+, which is filtered once, twice, 3 times. And then you should have 240 volts DC here as the B+ for the radio. So quite simple. And the other secondary winding for the filaments and for the dial lamp over here also quite simple and completely as expected in any other radio. Okay, so let's go on a very high level over the rest of the schematic. And let's go from left to right. So from the input of the antenna, so where the signal is coming in, until where it is leaving the tuner towards the amplifier. So here we have the FM can with the ECC85, and you see Philips, they always, or in my experience, they draw their tubes in a logical way. So you have the ECC85 here split in 2 parts because it's 2 triodes. So this entire section here is basically the FM can with the ECC85. Straight above it here, these are the bands for the AM. So you have the AM antenna over here on the top, and here you have the bands. Then the signal, whether it be from the FM or from the AM, goes to the ECH81, which is the mixer oscillator. It leaves that, goes through an IF stage to the first EF89, again through an IF stage to the second EF89. What you might already have noticed is that the switches here are indicated not by their function, but they are simply numbered. So SK1, SK2, SK3, SK4, and so on. And it took me a bit to figure out which was which. But basically, if you're just standing in front of the tuner, they are numbered from right to left. So let me show you. So this switch here on the right is SK1, SK2, SK3, SK4, 5, 6, and 7. So SK7 is the on-off switch, SK1 is the FM, and the rest are, SK6 is the band spread, and 2, 3, 4, and 5 are the different AM bands. So see, you have here SK1, which is the FM, and then 2, 3, 4, and 5, which are the AM bands, and SK6 is the band spread. And as you see, we just talked here about the EF89 and the IF stages in between. Here you have SK6, and there you have also SK6. So these are the band spread functions which are being enabled if you push down SK6. All right, so after the second EF89, you go here to the EABC80, and this one is also split logically in 3 different logical functions, just like the ECC85, because the EABC80 tube consists of 3 diodes and a triode. So here the first one is 2 diodes, the second part is 1 diode, and here you have the triode. Normally, in a normal radio, let's say, with an integrated amplifier and integrated speakers, the 2 diodes are used for the FM detection, then the third diode is used for the AM detection, and then the triode is used as a preamplifier before the signal is sent to your amplifier. Now here things are a bit different. The way the diodes are used is still the same, so you have the FM detector and the AM detector, but yeah, the triode, they didn't really need a preamp, right? Because all those things are handled separately in the amplifier. So the triode here, they could use it for something else. And this really is nicely explained here. Something interesting to mention about the FM part is that a noise suppression circuit is applied here to make sure that when searching for stations, you don't experience any noise anymore. So what they basically did is they It's basically a muting circuit, right, that they applied when you are in between stations. And then they go on and they say this noise suppression is achieved by connecting in parallel to C63, so this is a capacitor, the capacitor of the de-emphasis filter, to connect a variable capacity in the shape of B5. Okay, let's have a look what they mean. So I just opened the document twice now. So what they basically say is they are using here B5, which is the triode of the EABC80, as a variable capacity in parallel to C63. So C63 is this capacitor over here. And you can see that indeed this triode is connected in parallel, because this capacitor is on the C63 is on one side connected to the ground, just like the cathode here of B5, and on the other side here is connected to the both C64 and C65, which are going to the grid and the plate of the triode. So then they go on and they say when B5 is not conducting, its input capacity is consists of the capacity between the grid and the cathode, CGK, capacity grid cathode, which is also called the static input capacity. This capacity is very small. So that means, yeah, the capacity between the grid and the cathode. However, as soon as B5 is conducting, we encounter a dynamic input capacity, which is equal to the static input capacity, so the CGK again, plus the amplification factor, mu, of the tube, multiplied by the anode to grid capacity, CAG. So we have the dynamic capacity equals the capacity between the grid and the cathode, plus the amplification factor times the capacity between the grid and the anode. So you see that, yeah, as soon as your tube is opened, let's say, or is starting to conduct, then your capacity is going to increase, because your capacity is equal to the static capacity plus the amplification factor and the anode grid capacity. That's also what they say here. So the dynamic input capacity is much larger than the static. To make the input capacity even larger, a capacitor C64 is connected in parallel to the anode to grid capacity. So that's this one over here. And you see indeed that, so you have the capacity between the anode and the grid, and then you have C64 connected in parallel here. So when the tuner is not tuned into a station, B5 is conducting. And then see here, this is because you have here the ratio detector for the FM. You can spot him because the signal here is also going to the EM84 to identify or indicate your signal strength. It's also connecting to the grid. So it's also steering this triode. So when you are not tuned to a station, the triode is conducting. And C63, so that's this guy over here again, the capacity of C63 is then increased so much that the de-emphasis filter already starts to cut off the sound as of 1600 Hertz. And this greatly suppresses the noise. So see, when you are not tuned into a station, this signal over here is going to open the tube, which makes sure that the capacity of this circuit over here, or the dynamic capacity, as they call it, is growing quite large and is added here to the capacity of C3, which makes sure that you cut off more high frequencies. That's basically what it's doing. And then obviously the other side, when you tune into a station, the negative voltage over C67, So that's this guy over here. So that's our electrolytic capacitor in the ratio detector. Is growing so big that B5 is closed. So the tube here, the triode, is closed. So they also mention here that B5 is getting its negative grid voltage via R28, R31, and R30. So that's this chain over here. See, R28, R31, and R30. As a result, the input capacity is again CGK, so that's the static capacity, which is very small and doesn't impact at all the frequency characteristic of the tuner. So then again, it's the C36 here that is the major factor in the capacity of this filter over here. So yeah, I'm not sure I could have deducted the way that this was working without this explanation. And I really love how they explained it over here. I mean, you don't see this nowadays anymore, in an explanation of a product, how it actually the circuit is working. It's really cool. So they're basically using the triode over here as a way to reduce the noise when you are in between stations, basically as a bit of a muting circuit, right? So that's pretty cool. If we follow along the signal, then we get here to the EC92, which is the final tube before we leave the tuner. And yeah, an EC92 is a simple triode, but also they have an explanation over here why they put this EC92 in the circuit here. So they say the output circuit is contains a cathode follower. So as you see here, the EC92 is used as a cathode follower. So in short, what is a cathode follower? Well, a cathode follower is basically a gain stage in a tube, or using a tube, where you take your output signal from the cathode instead of from the plate or from the anode. So you see here the output signal is taken from the cathode. Not going to go into more technical details about this. If you just Google cathode follower, you can find lots and lots of technical explanations on the fine details of how this is working. And then they say here, that's quite funny how they phrase it. They say, well, it's a bit in old Dutch, so we wouldn't say it anymore like this these days, but they say, as can be assumed that is known. So basically like, yeah, you should know this, or you will probably know all this already. They say the cathode follower has a high input impedance and a very low output impedance. Because of the high input impedance, the detector circuit is not loaded, while the low output impedance enables a long shielded wire to be used towards the amplifier without the capacity of the cable affecting the high frequencies. So they took a bit of care here to make sure that they had a low output impedance so that the length of your cable wouldn't impact the audio quality of the circuit, of your signal going to your amplifier. Okay, so that's why the EC92 is here. And then they say also still something about the AM, where they don't go really into specifics. They just say that the input circuit for the medium wave and the long wave, they just say here that they really needed to have apply some extra care in this circuitry because the tuner is used in combination with a hi-fi amplifier, and every little whistle or every little noise or distortion of a neighboring station, you would have heard those in when you're using a decent amplifier. So they basically said, yeah, we took extra care when designing the band filters here for the AM, just to make sure that you clearly select an AM station and that you don't hear the neighboring stations bleeding in. Okay, but there are no real technical explanations for that. No, anyway, I really love the way that everything is described here in this service manual. So yeah, now we know what all the tubes are doing. I think it's Time to go back to the radio, back to the workbench, and see what we still can do there. So since we are talking about tubes, I thought, yeah, maybe I need to find a way to test these tubes, to identify the bad ones and know which ones I need to replace. And then I saw the video series online of Manuel from Electronics Old and New. Probably you've also seen the fantastic video series where he built a tube tester. And then I thought to myself, hey, I can do that too. So yeah, I also built one myself. Okay, yeah, that's maybe a bit mean from me, but obviously I didn't build this myself. I bought it this week because after I watched the fantastic video series from Manuel, which I would highly recommend, I'll link it in the description because it's a fantastic series and I think you should definitely watch it if you haven't already. I realized two things afterwards. One, I also want to have a tube tester. And two, I don't want to make one myself. Because even though how impressive it looks, the work that Manuel has done and all the explanation he gives, and you can also buy the PCBs online and everything. For me, I don't think I will have a lot of fun with such a project. And I am hugely impressed by the work that he did, but I think I wouldn't enjoy building one myself. And this is all a hobby, so yeah, it has to be still fun, right? So then, coincidentally, a very big coincidence, this popped up here online on a local second-hand site and not too far away from me, at a decent price and fully working. So I went and I picked it up yesterday, and the previous owner, Karel, thanks a lot, gave me a complete, exhaustive explanation on how everything is working. He spent 1 hour and a half explaining everything. Yeah, so I'm very happy with this device over here, and I'm now gonna use it to test all the tubes from the tuner. I'm not gonna bore you doing it all on video here. I'm just gonna test them right now, and then afterwards we'll come back and we'll discuss the results. Alright, so maybe as an example, let me just measure in EF89 because that's quite a simple tube. It's just one pentode. So first we put it obviously in the right socket. So first of all, I already put all the correct settings for the EF89 here based on what is in the reference guide. So let's have a look. So if I just flick this switch, we're gonna do a test of the anode current. Obviously we need to wait a bit for the tube warming up, and we expect 9 milliamps according to the reference guide. And this one is measuring 6.7 milliamp out of a maximum rated of 9, which puts the tube at just above 70%, I guess. So this tube, I guess it is still acceptable. It's definitely worn, definitely used, but it's still, yeah, now it's 6.7, so it's acceptable still. We can also measure the mutable conductance by adjusting here the grid voltage, half a volt below and half a volt above the 2 volts, the minus 2 volts that we have set it now. So then we can see the difference in the anode current, and we can calculate that one as well. So I'm gonna measure this at 1.5 volts instead of 2. Then we get 8 milliamp, and if I measure it at 2.5 volts, I get 5.4 milliamps. So 8 minus 5.4 is 2.6 milliamps per volt, and we're expecting here for an EF89 3.6 milliamps per volt. So it's also not great, but still within operating range and still acceptable. So I'm just now gonna go ahead and test all the remaining tubes of the tuner. Alright, so I have all the results over here. Most of the tubes are fine. Some of them are still really strong, like the EZ80, which is 96% measuring of the original value. But the EC92 and the EABC80 are not that great. The EC92 is only measuring at around 50% and the EABC80 only at 40%. So I do think that those will have to be replaced. Now anyway, I'm gonna, when the tuner is back in operating condition, I'm just gonna put these tubes in there and see what it does. But I do think that these two will need to be replaced. Alright, so the next thing I would like to do is start swapping capacitors. And I would like to start with this one. This is the filter can, and I need to restuff it. Well, I say restuff it, but it basically consists out of three 50 microfarad capacitors. And the replacement ones that I have are these over here. And it's gonna be a tight fit to fit 3 in there. I do think I'm gonna try. Maybe I can fit them in like this. But having to fit 3 of these in that can is not gonna be easy. Yeah, and see, this is the capacitor or the filter can from the bottom, and you can see that it's already bulging. So it definitely needs to be replaced. So yeah. And apart from that, I'm also gonna replace this electrolytic, that one over there, this tar capacitor, I think it is, and that also needs to go. Those are the only ones at first sight I'm definitely sure that I will replace, because all the other types of capacitors, I don't have a lot of experience with them. For example, these yellow ones over here, I don't know if they will still be good. I'll have to measure them. If somebody has experience with these types of capacitors, let me know. Do you think, do they definitely need to be replaced, or will they definitely be good? Or yeah. Anyway, I'm gonna measure those, because I don't know. I haven't encountered these yet. For the rest, there doesn't seem a lot of critical components over here. So that's the first thing that I'm now gonna do. Try to restuff the filter can, swap out these electrolytics over there, and then we're just gonna start measuring and checking resistors and other capacitors. And yeah, so I guess I'll know what to do. But yeah, I think I'm gonna leave it at that for this video. I don't think it makes a lot of sense to have me film swapping out all these capacitors. I'm just gonna do the work, and then you'll see the result in the next video. And in the next video, I'm gonna then, if these are swapped, I'm gonna do a first power up attempt of the tuner. So really excited for that, and I hope you are too. Thanks for watching, thanks for following along. If you'd like to see in the next video if it blows up or not, don't forget to subscribe to the channel. I noticed that I passed the 300 subscribers a while ago, but yeah, the more the merrier, so just follow along, like the video, subscribe, post a comment if you got a question or a remark. I'll try to answer to all of them. So thanks again for watching, take care, and see you next time. Bye bye.